Hey guys, my name is Narayan. I welcome all the viewers in this video and my YouTube channel. So guys, I'm just continuing with the concept of network certification CompTIA Volume 1, and in that today I'm gonna talk about so I'm beginning with this new concept, which is new lesson, which is other network protocols. And if you find helpful this video, please don't forget to subscribe my channel. The channel URL is here, and this is my blog. So the same thing is available here, and the old or previous videos are also available on my YouTube channel. So let me begin with this. And this what we are gonna learn about, identify the characteristics of NetBEUI protocol implementation, and characteristics of IPX SPX protocol implementation, characteristics of AppleTalk protocol, and identify the component of IP version 4 implementation, IP version 6 implementation. So first of all, in topic A, the net BU BI BEUI, how to pronounce it? It's quite difficult. So the full form of this one is, guys, very simple here. Let me tell you, NetBIOS Extended User Interface. Okay, the full form of this NetBIOS user extended user interface now is legacy protocol. Okay, commonly found in older Windows networks, and NetBIOS, this NetBIOS extended user interface is fast and simple and require no administrative configuration. We do not need to configure anything manually here, and administrator not required. It relies on NetBIOS broadcast traffic for node discovery and name resolution. So this broadcasting is responsible for that name resolution, and the administrator do not need to do anything here. Okay, and however this makes NetBIOS relatively insufficient because the broadcast create more traffic, network traffic overhead, and then other protocols. So the basic concept is like it is just it is not in use much, you can say, because it generates broadcast, and broadcast is always responsible for the traffic, network traffic. Okay, so let me talk about here. This is NetBIOS extended user interface, and for example, this is server 1, client 3, client 1, client 2 I have. So it will contain information like this. And what will happen here? NetBIOS extended user interface is implemented at the data link layer of the OSI reference model, and NetBIOS extended user interface identifies each node both by NetBIOS node name and MAC address as well. Because the MAC address has no location element, NetBIOS is not routable. Next, guys, in topic A only this much information. In topic B, topic B is the IPX SPX protocol. We will understand. So in previous topic we understood about little bit NetBEUI. Now we will talk about SPX and IPX. So IPX and SPX is what? Inter-network packet exchange or sequenced packet exchange. Is stands for IPX, and SPX is a proprietary routable network protocol developed by Novell in version 3 or 4. The Novell NetWare network operating system. So when Novell NetWare operating system were there, so at that time these protocols were developed. And IPX and SPX includes two protocol. IPX is a connectionless protocol, and network layer protocol that provides best effort delivery. And if we talk about SPX, is a connection oriented, just like TCP, and this is like UDP. So transport layer protocol that provides guaranteed data delivery. So in IPX there is no guarantee, but in XPX there is a guarantee of data delivery. So this is what the OSI reference model, in that it operates at transport layer and network layer. IPX is at network layer, and SPX is at transport layers. Because SPX is why reliable and why it is taking guarantee, because transport layer uses STP protocol. sorry, not STP, this is TCP, and it uses one more UDP. So TCP is more reliable and connection oriented, and at network layer it uses IP address. Next one is, guys, we talk about IPX and SPX node addresses. So all IPX SPX nodes are registered or assigned as 12 bytes IPX internet work number represented by 24 hexadecimal, and the first 8 hex digits represents the external network address and identifies the cable segment. The next 12 hex digits represents the node address and are unique to each network adapter. So this is what I'm talking about here. Certain things are very difficult to just uh, understand theoretically, and let me tell you here. So as you can see here, this is 1 2 3 4 5 6 7 8 8 hex digits. First one represents the external network address. Okay, so this is your external, and the rest of 12, this represents node number, and the rest of 4 socket number in this IPX or SPX address, node address. So this address is this is the complete you can say IPX or SPX node address. Next one is, guys, IPX and SPX server address. So servers on IPX or SPX networks are uniquely identified both by 8 character name and also by 8 digit hexadecimal internal network number. Both are assigned during installation. So at the time of installation itself, we have to assign those two things to servers. So as you can see here, this is your something like your route from internal address to multiple external addresses. If you want to make like that, then you will have to use multiple LAN cards, and this is your file server. So we'll have to add multiple LAN cards, and they will have their own IPX and SPX addresses. Next topics, guys, topic C, AppleTalk protocols. So AppleTalk is a routable protocol found in older Macintosh networks, and AppleTalk networks have hierarchical structure consisting of nodes, which are individual network devices like network also, which are physical logical cable segments, zones, which are administratively created work group that facilitates resource sharing and resource access, and sockets, which are addressable allocation within nodes. So again, if you see, this is what I'm talking about. AppleTalk supports various physical network topologies such as token talk, ether talk, and FDDI talk. So this is zone 1, and here you have one network. This is a socket, and zone 2 you can say a node. So and this is protocol suites, okay, of this AppleTalk. So it has multiple uh, protocols used in this. If you see this side, this is your OSI reference model, okay, and this is your AppleTalk. You should not be feel it is a single thing only. So in that we have couple of protocols like AF, AppleTalk data, ADSP, ZIP, ZIP, ASP, PAP, and they all have their own function here. So we don't use much Apple, so I'm not able to tell you much thing about. But if you see that the theoretical part of what are the roles of FP, ADSP, GIP, ASP, and PAP, you can read from here. Like printer access protocol, it is used by client to send data to print server and AppleTalk server to exchange data between them. So these are the, you can say, every protocol has their own role in this. And if you talk about the AppleTalk and IP TCP IP interoperability, so legacy AppleTalk network can interoperate with TCP IP based network also. So Apple and other third party net vendor provider provide AppleTalk over IP support to enable AppleTalk client to communicate with TCP IP network devices like Apple Share IP file sharing services enable Apple Share server to provide web files, print resources on client TCP network. So let me show you what does it mean. For example, this is what I'm talking about: Apple share IP, AppleTalk over IP. So what is this Apple share IP? So this is what helping us AppleTalk and TCP/IP interoperability. Okay, so what is this Apple share IP feature? So Apple share IP server product provides a bundled set of LAN and internet service to both Macintosh clients over AppleTalk and TCP/IP, and Windows client running TCP/IP addresses. It provides file and printer services, web server on FTP server, built-in support for Windows, file sharing, mail services that support internet standard mail protocol, and all lots of things it will provide to, or you can say these are the functionality of Apple share IP. And the next topic is, guys, the IP version 6 or IP version 6 protocol. So we will understand in this little bit thing about it. So first of all, we should be knowing IP version 4 address space. So the current version of IPTCP is IP version 4, although IP version 4 a theoretical address space of IP version 4 is vast. It is a 32 bit basically, and it is a classful, and it supports classless subnetting, which uses the address space more efficiently, has been widely adapted as of now currently, and it has certain limits like 32-bit address space itself, which provides theoretical maximum 232 or approximately 4295 billion separate addresses. The division of address space into fixed class and the depletion of class A and class B network address assignment, the unassigned and unused address range within existing class A and class B blocks. So these are the you can say the limitations of IP version 4. Now if we talk about IP version 6, so it is a 128-bit binary address. Okay, and it provides new efficiency features such as simplified address headers, hierarchical addressing, support for time sensitive network traffic, and new structured for unicast addressing. So it is you can say, as I told you, in IP version 4 there is a limit, but here there is no limit. It provides more addresses as compared to 4, and this could be you can say the small understanding about it. It is IP version 6 and 128-bit address space. And little bit more thing here, IP version 6 is not compatible with IP version 4. So at present it is narrowly deployed on limited number of test and production environment. So as I told you, there are certain limitations in IP version 4, and IP versions 4 and 6 are not compatible with each other as of now. So it is not deployed in production environment generally. But now there are certain technologies through which we can create tunnels so that 4 and 6 can communicate. Full adoption of IP version 6 standard will require a general conversion of IP router to support interoperability. So to make this communication IP version 4 to 6, we required certain routers to have that communication. And guys, there are certain unicast address, you can say, which is generated or supported by IP version 6. First one is global, site local address, link local address, IP version 6 transitional addresses. So you can go through the details from here. Next one is, guys, if we talk about IP version 6 address, so IP version 6 address space provides a numerous number of possible addresses combinations. It is a 128-bit decimal address is divided into 16-bit block, which are expressed in hexadecimal and divided by colons. Okay, so this is what your IP version 6 address, it is divided by colons, and every block will have 16 bits, and you can say 1 2 3 4 5, so like this. And if you want in detail, so this is what you can see in 128 bit decimal address. You can calculate like this and divide it into 8 16 bit blocks. So again you can count, this is 1 here, this is 2, this is 3, and this 4, and 5, 6, 7, 8. So 1 2 here, 3 4 5 6 7 8, 8 octet or blocks of 16 bits, and expressed in hexadecimal. So this is how we can convert in hexadecimal. And block of zeros are compressed. So here all zero blocks can be compressed. So how to do it, I have uploaded couple of videos about it in my previous videos. So if you wish to, you can go through my channel and you can find. And this is the, you can say, address space 128 bit again, and provides 2128 possible different address combination, which is approximately equal to the number 34 followed by 37 zeros. Okay, and this could be the number. So this many IP address will be provided by IP version 6. I cannot count this, how to count. So guys, thanks for watching for this video. And this video, this much information only, and this 8th chapter is also over now. If you find this helpful, please don't forget to comment, like this video, share this video, and subscribe my YouTube channel. And in next video I will be talking about lesson 9, which is local area infrastructure, and in that I will have couple of topics like LAN networking, LAN routing topology, static implementation, dynamic routing, filters, and all VLAN. So if you subscribe, then you will be getting updated videos. So guys, till then, bye bye.